So the second one we want to talk about is called selection sort. And this sort also will sort your array into ascending or descending order. And the way this one works is the first step, so I'm going to do the same thing with this. I'm just going to write down the general algorithm, and then we'll look at the code for how this would be implemented. So the first thing we're going to do is locate the smallest element in the array. And what we're going to do is once we find the smallest element in the array, we're going to swap that element with position 0. So basically we're going to search the array, find the smallest element, and then we're going to swap that with the first position in the array. So we basically put the smallest element first in the array with this first step. So I'm going to say once we find the smallest element, we're going to exchange it with position 0. The second step, just really generally, is that we're going to locate the next smallest element and exchange that with position 1. So I'm going to we're going to locate the next smallest element and exchange with, stick with the same terminology, so position 1. And then we're just going to continue this until we reach the end of the array, right? So if we keep finding the next smallest element and putting it next in the array, if we go through the entire array doing that, we'll eventually reach the end of the array, and our array should be in order at that point. So I'm going to put that we're going to continue until the elements are in order. All right, so what I'm going to do is write out the code like I did last time, and then we'll just step through it and look at how it's working. So let's just say that we have a function, call it void, and this is selection. Let's just call this selection sort. So int and the size. This time I'll make it capital because this is a constant. And then we're going to have two variables. So we're going to have the minimum index and we're going to have the minimum value. So min index and min value. And these are both integers because there's going to be whole numbers. So what we want to do, we're going to have a nested for loop again. So we're going to have an inner and an outer loop. The first loop, let me just write this. So we're going to just call this start. So this is where we're starting, and then start less than size minus 1, start plus plus. So initially our minimum index and our minimum value are going to be set to the first element in the array. So we're just going to say that min index is equal to start, and then min value is, if we want the minimum value to be set to the first element in the array, this is going to be array start. All right, now let's do an inner loop. And so this one is going to be, I'm going to have int index is equal to start plus 1. And we're going to see in a minute why we want that to be start plus 1. Index less than size, and then index, plus plus. And then we want to do a comparison in here. So we want to say if, so basically with this one, we're stepping through the array, and we're going to compare each value in the array to our minimum value. And if our array index, if whatever we find stored in the array as we're stepping through the array is less than the current minimum value, we're going to, we're going to reset our minimum value and our minimum index to whatever we find to be the actual minimum value, and then we're going to swap those values. But we have to go through the entire array first before we know if we've found the minimum value or not. So this is going to be if, and I'm just going to say if array index is less than the minimum value. So this inner loop is stepping through the array and comparing each value in the array to our current minimum value. So if we find that the current index in the array is less than the minimum value, we're going to reset the minimum value to whatever that value in that index is. And we're also going to set the min index to the current index, because we know that those are the minimum, we know that that's the minimum value. And then after we finished running through this for loop, we know that we have the minimum value in the array stored in our minimum value and minimum index variables. So we're just going to swap whatever that minimum value is with whatever we have in first time we run through with position 0. So let's just do our swap function again. Let's look at the same array we had before. So 10, 5, 40, 35, and 6. And this is 0, 1, 2, 3, and 4. So let's do what we did before and just write down what our different variables are equal to right now. So first of all, when we come into this for loop, let's start with the size of the array. The size of the array is 5 because it's the same as it was last time. So let's say, okay, so size equals 5, and that's not going to change. And then when we first come into this outer for loop, start is 0. So let's write that down. Start is currently equal to 0. Min, that means that min index, so min index is equal to start, and min value is just equal to array start, so whatever we have stored in index 0. So we can write down what these are currently equal to. So min index is equal to 0. So min value is 10 because our index is currently 0. So we're looking at what we have stored in index 0 of the array. So min value is 10. And then now we've started this outer for loop. Now we're at the inner for loop, and we have the index. Let's just write this down. So index is equal to 0 plus 1. So index is equal to 1. So that means this inner for loop is starting here. So basically what we've done is we've said we're going to assume that the first element in the array, which is at index 0, is our minimum value that we have in the array. And then we're going to go through the entire array with this inner for loop, and we're going to compare each value in the array to 10. And if we find one that's smaller than 10, we're going to say, oh, well, that's actually the minimum index and minimum value. Well, that's the minimum value, and it's at this index. And then after we've gone through this inner for loop, we should have the smallest value stored in min value, and we know what index it is, so then we can swap that index with 0, assuming we're on our first, with index 0, assuming that we're on our first loop. So now, we're at this inner loop. Index is equal to 1. Our if statement is if array index is less than min value. So what we're comparing is if 5 is less than 10, true. So that means that this if statement is going to run because it's true. So now what we're going to do is we're going to say min value is equal to the current index, which is 5. So now min value is equal to 5. Min index, is equal to index. So min index is equal to 1. And so now we've just changed those two variables. Now this is going to run this for loop again. So this inner for loop is going to repeat. Now we've incremented index. So now index is equal to 2. And so it's right here. And this is our if statement says if array index is less than minimum value, array index is 40, so this is saying is 40 less than, and what we currently have stored in min value is 5, so is 40 less than 5? No, that's false. So it's not going to restore anything in those values. They're still going to be equal to what we had set them to previously because that's false. It's going to find that this one is false and this one is false as well. And then that's going to be the end of the inner loop. So we've gone through the inner loop once now. We now have the minimum value stored to min value for the array, and we also have the location of that minimum value, so the index. So that's where the swap comes in. So we've gone through the inner loop. Now we're going to swap, and let me write down the code for, so we're not going to write the function for this swap, but what we're going to be swapping is the minimum index with the starting position of the array. So the first time we've gone through this array start, this is array 0. And then we found that our minimum value is in index 1. So what it's going to do is swap the 5 and the 10. But see how, like this one, with the bubble sort, we just compared 5 and 10 and we swapped them. But with this sort, we actually went through the entire array, and so now we know that 5 is actually the minimum value in the array. So we're directly taking the lowest value and we're putting it at the beginning of the array. So this one is a little more efficient so far. Let's redraw our array. So after we do that swap, we're going to now have 5, 10, 40, 35, and 6. All right, so now we're back at this outer loop. So we're here again. And notice how with the start, we have start plus plus. So we've incremented start. Start was 0. Yeah, so now start is equal to 1. So let's write that down. And then if we look at, if we look at the code, so I'm looking, let me erase some of this. So I'm looking at these two statements. We're going to reset the minimum index and the minimum value. So now what we're doing is we're assuming that we already know we have the lowest value in the first position. So what we're going to do now is go to the second position, and we're going to say, okay, well, we're going to assume that whatever we have stored in that second position is min value, min index, and we're going to go through the array again, the same way we just did, and find the next lowest value and store it in the second position. So currently let's look at exactly what the code is. So min index is equal to start. So min index is equal to 1. So min index is equal to 1, and that means that min value is 10. So it's what we have stored in index 1. So now we're back at this inner for loop. So we're right here. And so index is now equal to start plus 1. Start is 1. So start plus 1, 2. Index is equal to 2. So see how we're starting our search from, well, we're actually starting the search here. So we're assuming that this value is our current minimum value. So we don't need to search the entire array again because we already know that we have the minimum value in the first position. So we're going to go to the next position in the array and not worry about the first position. And we're going to search, and we're going to assume that this second value is the minimum value. We're going to search the array, compare that value to every value in the array again, and find the actual minimum value so we can swap the whatever value is the actual minimum value with that value. So the way this is going to work, let's say that we have, so index is equal to 2. We're going to be comparing, and let's look at this if statement. So we have if array index is less than min value, so I'm looking right, erase this again, so I'm looking right here. So we have if 40, what was that again? Yeah, if 40 is less than 10, this is false. So it's not going to do anything with that if statement. If, let's go to the next one, 35 less than 10, false. And then let's go to the next one, so this loop is going to increment again. So if 6 is less than 10, this one's true. So it's going to run this, it's going to run the statements in this if statement again. So we're going to reset the min value equal to the array index. Well, actually, the min value is going to be equal to 6, and the min index is 4. So this is going to reset these values. So min index is now equal to 4, and min value is equal to 6. So then this is basically going to end that inner loop now because we've reached the end of the array. And it's going to, once it reaches the end of this for loop, it's going to go into this swap again. So what it's going to do, and this is where this is more efficient than the bubble sort, it's going to swap 6 with 10. So we've located the minimum value in the array, and we're going to put it directly into the whatever place it goes to be in the correct order. So let's swap these. So now we have 5, 6, 40, 35, and 10. And notice how we swapped the 6 and 10. So when you do the swap, you don't want to just copy 6 to 10. You need to put 10 somewhere so you can keep track of what you have. And then this is going to, once again, go into the outer loop is going to increment again. So if we go look at this outer loop, we have int start. Start is currently equal to 2, so now start is equal to 3. So this is going to start here. It's going to set 40 equal to the min value. Min index is now equal to 2. And it's going to go through that inner loop, find the 10, and it's going to directly swap the 10 and the 40. And after it does that, it'll likely go through this one more time just to, because it's going to finish going through the loop, or the loops, but so it's going to be 35 and 40. It's going to go through it again and find that 35 and 40 are actually in order. But notice how each time we're running this, it's doing one, like we're basically starting our search through the array at one element over. So we're searching a smaller array every time. The benefits and disadvantages of this sort. Probably the only disadvantage of this sort is a lot more efficient than the bubble sort because it puts your value directly into order. So the disadvantage is that this algorithm is harder to understand. So I'm just going to put hard to understand. But the benefits are that this is more efficient than the bubble sort. And the reason why is because there's fewer exchanges, because we're putting our value directly into place.